Welcome back, Raiders Precalcsters. Today, we are finishing up our non-linear inequalities. And geez, look, hold on here. If I just look through here, 2.6, 2.7. Huh. Well, isn't that kind of strange? There's no 2.8. I can feel the excitement. Okay, we'll obviously deal with this here shortly. But last little piece, I want to try one variation of a problem. Last time I'm going to reference this, probably not really. When can a function change signs again? At its vertical asymptotes or its roots. So, last little piece of this section, and this one really is the last little piece. We'll do a problem or two or three. But we're going to define today, and let's see what we've been calling everything. So we used nonlinear inequalities, and we dealt with some of these guys that are nice. They're just our big polynomials. You know, all those were polynomials. We better knock out some rational inequalities real quick as well.
Mr. Howard,
Is awesome.
did you guys go over the answer for number B?
That's where you did not record.
I don't even have it anymore. Did we talk about the weird solution? Didn't I say that was a 1-point homework assignment or something? I don't know. Do you guys have example B?
Yes.
Can you read it to me?
Oh, we didn't finish.
X squared minus 2x is greater than or equal to negative 1.
Okay, so I'm going to do that. Okay. I'm just going to factor this guy really quickly. And my bad. If this was a problem that we forgot to finish, I had to erase stuff you saw. Like, sorry. Did you guys factor this yet?
Yes.
How's it factor?
X plus 1 squared.
X plus 1 or x minus 1? It should be minus 1 squared is greater than or equal to 0, right? Now, for this, I would actually write equals 0 here because this is the part that I care about the inequality. What does it mean to be greater than or equal to 0? It's positive. That's what it means. Okay, can you tell me where the roots are of this function? At 1. Now, this is a weird question, and you might answer it a couple different ways. How many roots are there? Good. And they just both happen to be the same, right?
Yeah.
So here we go. 1. Pick either the left interval or the right interval to test real quick.
Left.
The left is the one that I would pick. Why did you choose that one? Because 0. Okay, so if I plug in 0, 0 minus 0 plus 1 is 1. 1 is greater than 0. True or false? Or rather, 1 is positive.
True.
There's a plus here. Okay, how many times did this root show up? I'm going to ask the same question worded differently. What's the multiplicity of this root? 2. Is that an even number or an odd number?
Even.
Which means it does what? Bounce. Or I use touch and turn, but if it was positive and then it hit 0 and then it turned, it's still positive. Now, this one, there's nothing really that crazy about it. You may be tempted to say it's negative infinity to 1, union 1 to infinity. And I can see where how you can get that answer. But or equal to in this problem. What is the value of a function at its 0, its x-intercept, its root, its solution? What is the value of a function at the x-intercept? It's 0, right? Like that's what it has to be. It's called a 0. Is 0 greater than or equal to 0?
Yeah.
So what I see is everything left of 1 works, everything right of 1 works. Does 1 also work?
Yes.
So if every possible number works, how would we define this? X such that x is
All reals.
in the reals. Boom, and we have it. Thank you for the reminder, Edison. Did you guys all come up with the same thing?
Yeah.
Did everybody finish the problem, or did you just finish it with me?
Already.
Okay, cool. So back to this. Rational inequalities. Okay, these ones, they're going to seem like they're harder, and they may be a little bit more labor intensive. Notice I didn't say harder, it just maybe a little bit more work, because there's really nothing that changes when we make the jump from our polynomial inequalities, which is every example that we've done so far, to here. Same process, they just have one little extra added piece. So here we go. We're going to work a couple of these together, at least one. If we need another one, we'll do it. I want to know, when is it the case that the following rational function, which is x minus 2 over x minus 3. Sorry, I should have written out the stuff here, but that's okay. I want to know when is this greater than or equal to negative 3. All right. Now, it's uglier, right? Because it's irrational inequality instead of just a polynomial. But greater than or equal to negative 3 doesn't really mean a whole lot to me. What would I like it to be greater than or equal to? 0. What could I do to each side of this equation, or inequality rather? Can I add 3 to each side right off the bat? Cool. So I'm going to switch to a red color for the rest of it. I now have x minus 2 over x minus 3 plus 3. And I'm going to leave an awkward space here for a reason. Greater than or equal to 0. What does this mean? Positive. And to this day, like every time if I were doing a problem on my own, I do take the little bit of time to write out this means it's positive, because it's easy to get goofed up. And if everything else is right, but you get that part wrong, there goes your problem. Now, the left side of this expression, meh, not really that convenient for me. I left an awkward gap. Why? Talk with your neighbors. Why do you think I left an awkward gap? I did it to save some space for writing our next step, but there's something that I have to do to really deal with the left side. 30 seconds, I'm going to call in somebody random. If I want to actually combine these, can I write this second? Not yet. Why? We need a common denominator, right? Like we need to be able to combine these things. And I'm not sure if multiply by the bottom thingy was that or not, but do you guys agree that if we had a single fraction, it'd probably be easier to work with? So let's make a single fraction. Now, to do so, we're going to multiply by a clever choice of what number? 1. Now, we have infinitely many choices for how we write the number 1, but I know the way that I think we should write it. X minus 3 over x minus 3 to ensure that we get a common denominator, right? Okay, I'm going to do a little bit of mental math here to save a little bit of work. We're going to distribute here, right? 3x minus 9. So on my next line then, and I'm just going to say this becomes and implies the next line, implies the next line. I'm going to have x plus 3x, so I think it's going to be 4x. And then minus 2 minus 9, I think it's 4x minus 11. I'm just cleaning up and distributing in one step over x minus 3 still is greater than or equal to 0. Are we, go ahead. Bless you.
Oh, never mind, I see.
Okay, just in case that other questions coming up, I will show 2 lines, just in case. The line that you saw me skip was I have x minus 2, and then we'll do this, plus 3x minus 9, but everything is still all over x minus 3, bless you. And I think I get the same thing. Do you guys agree? Okay, so, gosh, my memory is so bad. When can a function change signs from positive to negative or vice versa? At vertical asymptotes or the roots. So here's the big piece that, again, we haven't been graphing these. What makes a vertical asymptote? I love both of those. When the divisor is 0 or zeros of the denominator. Can anybody tell me a value for which the denominator of this thing is 0? 3. There's a vertical asymptote. Okay, this is the first inequality that we've had with an asymptote included. Doesn't add anything other than one step to find it. Okay, how do you find the roots, the zeros, the x-intercepts of a rational function? The denominator 0 makes it vertical asymptote. What makes a root? I'm going to win this game for the record. Oh, say that again? The numerator. Okay, so check it out. I'll do a little bit of scratch work here. The numerator is 4x minus 11, and I need to know when is that equal to 0. Well, I'll add 11. And then I'll divide by 4. So I think we just determined, or at least I did, and hopefully you agree, 11/4. If you don't need scratch work, is that fine with me? Yeah, if you need scratch work, is that fine with me? As long as you're doing math, it's fine with me, like for real. Okay, now this problem, slight difference. We're still going to run the same way, but maybe we can't use all the same tricks. I have how many numbers I'm going to put on my number line? 2. These both go on number line. Now, the number line that we're working with, just as a reminder, it's really and truly the x-axis. I just don't draw the rest of the graph. So here we go. I'm going to put these, that's unfortunate. I'm going to put these on a number line. What number comes first? 11/4, that's like 2.75. And then here's 3. Now, in this particular problem, I am going to add one little piece. Whether you write it here every time or not is up to you. I am going to note that this is a vertical asymptote, and this is a root of multiplicity. And I'm going to even change a word. How many times did this root show up? Can I just say of odd multiplicity? Okay. Now, whether you write it or not is up to you, but this is a thought that should be in your head every single time you write the root. The odd multiplicity means that my graph does what? Crosses or changes signs. So right now I have 3 intervals. I need a number to test in any of those 3. So 2 is an option. Which interval is 2 in? The left. Is there an easier number? 0 is the choice. So I'm going to test 0 here. Now, I will go back to my other color. I guess we'll go to red here. I'm going to test 0. And we're going to plug it into F. And it's weird because I'm going to do it in this step. Now, it doesn't really matter if I plug it in here or here or here. They're all the same, right? Which one do you want me to plug into? A or B or C? C, indeed. If I plug in a 0, I get 4 times 0 is 0 minus 11, so I get negative 11, over 0 minus 3 is negative 3. Don't really care that it's 11/3, but I do care about the sign. It was positive. Now, I'm just going to double check if I had plugged it in here instead. Negative 2/3 plus 3, is that also positive? Yeah, negative 0.67 plus 3, definitely positive. Okay. What's up?
6, 7.
Okay. Give me a number in this middle interval. This is the one time that I'd say decimals are like your friends here. Because the second that I saw people go, like, you worry about it. 2.75, right? 2.76 would work, or 2.77. If you're trying to make it a fraction, it's obviously harder, right? Find a fraction between 2 numbers. 2.76. Cool. I don't know how to say it backward, otherwise I would have. Gross, but I'm just going to check. Let's do 2.9, right? That's pretty close. If I do 2.9 and I plug it in, I don't know, let's do it here. 2.9 minus 2 is 0.9.
Why?
She's remembering a joke I told last week. Okay, 2.9. Let's try it. This would be a 0.9, right?
Yeah.
In the numerator. And I'm using A right now. Basil, if you're watching and I just can't see it. So I get 0.9 over 1/10 if I use 2.9. Negative 1/10. So that's 0.9. That's negative 90. Right? I think. Plus 3. Negative. Now, if you don't want to check this, you don't have to, because the fact that it's an odd multiplicity tells me I should have been expecting a what? If you want to use 2.9, you can, or you can use multiplicity to say it's negative here. Okay, can I just switch right to saying positive? No. How come? It's an asymptote. The multiplicity rules no longer apply. Pick something obnoxiously in this interval. I'm going to be more obnoxious. 10. Now, you could pick 4, 5, 6, doesn't matter. But if we pick a 10, 40 minus 11 is a positive, and 10 minus 3 is a positive, and a positive over a positive is? So it was positive. Now comes the last little part where we have to put it together and actually write our solution. So originally this question was asking, where is it greater than or equal to 0, which is positive or 0. First thing, did we talk about graphing on here? With open circle and closed dots and stuff? Okay, Abijah.
So, why can't you use the multiplicity for the
Because zeros have multiplicity, and this is not a zero, this is a vertical asymptote. Yep, only reason. Great question. If the question didn't get hit in here, it's why can we use multiplicity for this root but not this one? It's because this is a root, this is not. Okay. So, here we go. Last little thing. If you want to graph them, you can. It's not required. Is it okay if a value is 0 to be greater than or equal to 0? So if I wanted to put a point here, would it be open circle or closed if I can include it? Closed. Now, you don't have to graph these, and I'll make sure that you don't graph it on the test, but it's nice to have a way to do it. If I want to go from where it's true, which greater than or equal to, 0 is okay. Should I go left or right if I want it to be positive? Left. How far does this go to the left? To negative infinity. Okay. Now, this whole interval in here, none of it works, right? Because it was negative, but we need it to be positive. Above 3, open circle or closed circle? Why open, Dolan? You're right. I can't use this x value. I can get as close as I want without touching it, hence the open. And then which way should this push if I want to go all the way positive? Left or right from here? Now, if you hear that question, you're thinking, I'm not sure how. It's because the positives are to the right. Okay, if you want to include these, here is the graph for it. Your book, I think, uses a different notation. They use this, and I hate it. They use a bracket like this, and then they use a parenthesis like this. But it's the same thing, dots and brackets, open circles and closed circles. It's just whether we include it or not. This whole number line, drawing the actual graph of it, is only there as an aid if you need help writing your notation or writing the answer in the correct notation. Yes, miss?
How did you get the closed circle?
Because can it be equal to 0? Equal 0 is okay or not okay based on greater than or equal to.
Yeah, but that was 0.
So that one's fine. I'm sorry?
I understand that, but the point's not at 0. That's why I was confused.
So the y equals 0 is fine. Because this is a 0 of my function, right?
Oh. Oh, no.
But this is y dividing by 0, not. Is the only reason that one's filled in and one's not.
So is there only going to be an open circle at the asymptotes? Or
Unless this were just greater than. If this were just greater than instead of greater than or equal to, it would still be open circle. So that didn't seem like it clicked. Don't change your whole problem, but let's say it was just this along. At 11/4, the value is 0, right? Is that greater than 0? Is 0 greater than 0? So if that's not the case, I would use an open circle. But because it was or equal to in our problem, it's okay if it has a value of 0. We can still use it. We'll get practice with that because I don't think I really cleared that up for you yet, but I think that just getting a few of them in practice will. Okay. What I really need, though, is to write my answer. My solutions for this inequality are going to be all the x such that, do we want to use interval notation or do we want to use, like, inequality stuff? Okay, so this first one, x is always less than or equal to something. 11/4. Or, there's another option that works. X should be greater than 3. Now, the inequalities just happened to win only because whoever preferred inequalities was more confident in it and they were louder and faster. But check it out. We can do it with interval all the same. This first interval, x is in. How far to the left does it start at? So negative infinity, and we can keep plugging in those x's until we get to 11/4. Did I include or not? And how do I indicate I include it with an interval? You bracket, which is exactly what we saw on the number line. It just looks ugly if you put those on there. How do I tie this interval together with this one? They get married, or the union, right? And then this interval, from where to where? 3 to positive infinity. And what about 3, bracket or parenthesis? Love it. I don't have a strong preference which one you write. And in all reality, if you, like, did I talk to you guys about using the x in the set of stuff last week? If there's an infinity in it, I'm not going to be confused. Nobody will ever be confused what you're talking about, but it's a good habit just to get used to doing this. Did this problem, bless you, did this problem feel significantly harder than all the others? Like, there's a little bit more, right? We just have to worry about the asymptotes. But if that's the only addition, I want you guys to try some. We have a ton of time. A ton of time. The good news is I need it to be able to find my homework because all my notes fell. Do not have to, you have to do the number line, but you do not have to do a graph on the number line. Like, if you don't want to, if you're struggling to get stuff in the right order, I will probably make you do it, but I'll come and rehit it if it didn't make sense. All right. So, everybody cried all weekend because there was not a ton of homework, right? Yeah, I could feel it. There's a song about Venezuela. Yep. Don't Cry for Me. That's a Venezuela song, right? Okay. It was Argentina. Don't Cry for Me, Argentina. Thank you. Don't remember why I was wondering that, but here we are. Ooh. I don't know why I didn't do these days. Probably because we didn't have homework, huh? That makes sense. We didn't have homework 3 days last week? Well, I got you. Don't worry. Homework 2.7. You guys will find Waiting Lovingly on page 187. And you're going to be shocked about this assignment. I just want to get the sticker shock out of the way. 20.
Good or bad shocks?
I don't know. What do you think? 20, 26, and 43 do 10, 21. Now, you might notice the shock of this is that it's so much shorter than every other problem or every other homework set, right? Why do you think I'm making this so short?
Oh, no, they have multiple parts. They have multiple parts.
Oh, maybe, but what did we say earlier? What are we going to cover in 2.8?
We have
Oh my gosh, there's no 2.8.
Lord mercy.
We're just going to start calling them the prac test because I think that practice test alliterates nicely to prac test.
Is it a quiz or a test?
Is it those team tests?
So,
Oh,
yes.
ready for a test.
I guess we can. Do you guys like and appreciate democracy?
Yes.
That was a very tilted question. If anybody said no, I was going to destroy you right here. So the question came up, is that a team test? Traditionally what I've done is practice tests are, the team test counts as a quiz grade. It's like out of 50-ish instead of 100. Do you want a quiz? Like this is the very first second grade after the homework. If it's not a quiz, and I want, like, people are saying no, but I want you to be very aware of this. Even if it goes poorly and we have to take it home, I just take the value of the quiz down. If you are given a quiz, a practice test, with 3 to 4 people, should you do okay on it, assuming that at least one of the 4 people is okay at the stuff? If it goes long and you have to take it home, whether you have somebody to work with or not, should it go pretty well if you can now open your notes, open your book, do all that stuff? Should this be an easy, good quiz grade then? Theoretically, it should. Do we want to make this a quiz grade, or do you just want it as a practice test in class, like assignment, and then there's no grade other than your homework and your test? We're going to close eyes. I'm just going to trust you guys. I don't really care if it goes in as a quiz or not. I have always done them as quizzes because they're like grade buffers, essentially. It's a team quiz, yeah. It'd be a team test is what I call them. I just go in as a quiz.
Notes or no notes?
If you don't take it home, like as a team test, it will count as a quiz grade.
It will count as a quiz grade either way. It's just either a 50-point quiz or a 25-point quiz. You know what? We're just going to call it quiz. I'm going to, whether you like democracy, you all do love democracy, but we're going to authoritarian this real quick. We're going to count it as a quiz grade because it should go well. Now, naturally, I'll call that team test. The question is, can we have a note card? And traditionally, yes, it's always been a yes. Here's what I'm thinking. You do not get a note card for your test. Your test, you do not get one. If you want one for your practice test, and even if you make one for your practice test and then you make one for your test, just the process of actually making the note card is a good way to study stuff. I'm going to say you can use them on the practice test, but we're going to go test-free, note card-free test. Cool, cool? All right. I'll have you guys do it to it. I'll save and post the video. Basil's a huge nerd. We'll see if she really watches this.